can all imagine an ice cube. We've seen them before. They're pretty much everyday objects. Now, can you imagine that same ice cube, but 188 miles long, or 3 miles tall? Now, you're thinking of a glacier. Glaciers are pretty amazing, and after the next 5 to 7 minutes, you're basically going to be an expert in the subject. You'll learn about their components, about their formation, about how they move, about glacial landforms, about mass balance, and about why we need to stop climate change. So, I might have misled you before. Glaciers are not simply blocks of ice. They are actually flowing masses of compressed snow with visible features and components. The lowest end of a glacier is called the terminus, or the snout. A crevasse is another glacial feature. It is a large split in the glacier which is formed when glaciers suddenly move very fast. There are often dark stripes of debris on glaciers called moraines. There are medial moraines in the middle of the glacier and lateral moraines on the side. They can also be formed when two glaciers run into each other, such as in this image. Glaciers also have features formed by meltwater, such as surface ponds and moulins, which are vertical channels in the glacier. You may be wondering now how these complicated blocks of ice and snow are even formed. Glaciers are formed when enough snow accumulates that it turns to ice. This happens over many years. In order for the ice to form, new layers of snow need to compress the previous ones. As the snow is smushed, it turns to firn, which is a state between snow and ice. According to the National Snow and Ice Data Center, for most glaciers, this process can take more than 100 years. It might seem weird that all this ice can move, however, it's pretty simple. One of the biggest aids to glacial movement is our old friend, gravity. Remember how big glaciers are? That's a lot of ice, which equals a lot of mass. This mass causes internal deformation, which causes glaciers to move out and down. Glaciers also can move by sliding. This is called basal sliding and happens because there is usually a small bit of water under glaciers. This sliding usually happens to extra cold glaciers on extra steep hills. Of course, the movement of glaciers has potential to change the landscape significantly. Glaciers are extremely powerful, which is evident by the way they can create such amazing landscapes. One type of glacial landform is a cirque. This is a semicircle in the bedrock formed when the starting point of a glacier erodes into a mountain. You can see it in this image. Glaciers can also change the shape of river valleys, which are then called U-shaped valleys because they're in the shape of the U, like this. Two types of mountain peaks formed by glaciers are aretes and horns. Aretes are sharp and thin and are made by two glaciers. Horns are carved by multiple glaciers, but they are pyramid-shaped. Here's a picture of an arete. While all those are erosional features, glaciers can also form depositional features. Moraines are depositional features which you already know about. There's also a feature called a kame, which is a hill formed of sediment which was deposited by glacial meltwater. One more type of depositional features are erratics, which are boulders which have been transported by glaciers. They are interesting because they indicate the flow of glaciers long ago. Here's an example. Many of these depositional features were made by glaciers which are now gone, which brings us to the topic of glaciers retreating and therefore mass balance. According to antarcticglaciers.org, glacier mass balance is the quantitative expression of a glacier's volumetric changes through time. Although that makes it sound confusing, it's actually very simple. Mass balance is just expressing how much ice the glacier is losing and gaining. You can think of it as the equation mass balance equals accumulation plus ablation. A glacier's mass balance is positive when it gains more mass than it loses and negative when it loses more mass than it gains. If the loss and gain balance each other out, the glacier is in equilibrium. Glaciers with a positive mass balance will advance, glaciers with a negative mass balance will retreat, and glaciers that are in equilibrium will stay where they are. When talking about mass balance, we split the glacier up into two zones, the ablation zone and the accumulation zone. We also have the equilibrium line. The ablation zone is the bottom part of the glacier, where it is losing mass to processes such as calving, meltwater runoff, and wind-blown snow. The accumulation zone is the top part of the glacier, where it gains mass because of precipitation, avalanches, or frost. The equilibrium line is the imaginary line where ablation and accumulation are equal. The altitude of this line is often the snow line. Unfortunately, many glaciers are retreating because of climate change. Even though glaciers probably don't directly affect many of you, the retreat of glaciers due to climate change is simply catastrophic. Glaciers do have a direct effect on many people's lives. According to the National Snow and Ice Data Center, glaciers provide drinking water, irrigate crops, and generate hydroelectric power. Glacial runoff also provides habitats for animals and plants. If the fact that glacial retreat hurts many other living things doesn't make you passionate about saving glaciers, maybe the fact that sea levels will rise as a result will. Sea level rise would cause changes in ecosystems, infrastructure damage, and coastal flooding. It would definitely affect us. My last piece of evidence as to why glaciers should be important to us all is that they are simply beautiful. Here are a few pictures of glaciers past and present which illustrates the magnitude of this problem. As you continue on with your day and your life, please think about what small things you can do to help prevent this tragedy.